is start discussing these, and you are going to give me, people that have done it are going to give me answers. Okay? All right, let us begin, cabbages. What is the surface area of the first one? 150 what? Meters squared. Now, is there anybody in the room that needs to know how that number was arrived at? Or is everybody good? Excellent. Good. Now, in this one, I told you that this was a 90 degree. So you had this triangle here. What is that surface area? Who has a number for me? Zach. 146. I don't remember if that is correct, so I'm going to keep this question open to see if anybody else has another number for it. Does anybody else have another? Holly, what do you have? 194. Does anybody else have a different number than that? Toby, what do you have? 216. Does anybody have a different number than that? Dan? 132. 132 centimeters squared. And Gervir? 173. Just 73. Okay. 73 centimeters squared. Now, as a math teacher, does this concern me? Very much so. Why? You all got a different answer. Even though we just went over surface area, and every 2 seconds I stopped and said, is everybody cool with this? And everybody said, yeah, right? So that means even if you were all wrong, I would have expected similar answers. But we are all over the map here, aren't we? Okay? You have a 194? Okay. So obviously we need to talk about this one. So, surface area is what? It's the total outside, right? If I were to take my blue highlighter and paint this thing, that would be the surface area. Does everyone agree? Okay. So, let's pretend that we don't ever have any formulas for whole prisms, right? Because we have a formula for this guy. He's 2WH plus HL plus LW, right? We have a formula there. But when you looked on your formula sheet, there is no formula for a triangular prism, is there? There's one for pyramids, but not a prism. So if there's no formula, we have to actually think about the sides. Everybody understand? So, I'm going to use red. Can anybody tell me, there is a triangle, yes? What happens on the other side of this prism that you cannot see? That triangle repeats, doesn't it? Everybody agree? Making what shape? Not a square, a rectangle. Which means, what is the area of that? How do I find the area of that red rectangle? Length times width, which is 6 times 8, which is what? 48. So the front triangle and the back triangle are 48. Is everybody cool? Yeah. All right. Now, what about this? What about that? What did I just make? That's the bottom of it. You can't see it. What is it? It's another rectangle, isn't it? It's not a square because it's 8 and 7. It looks like a square, but it plainly says it is 8 and 7, right? I look like a movie star, but yet here I am teaching math in Abbotsford, right? Looks can be deceiving. See what I did there? It was a joke. It wasn't cheeky. It was a joke. It wasn't cheeky at all. Famous people come from Abbotsford. The Wasp is from Abbotsford. Yeah, my dad. Evangeline Lilly. Her dad's a teacher in Abbotsford. Or, I don't think still is. I think he retired. I mean, I would have retired if my kid was suddenly if my kid becomes super famous, that's like just this side of winning the lottery. I will be retiring so fast and becoming his manager.
He was in the 100s.
Yes, he was. Maybe. We'll see. So, That is again LW, yes? What is it? 8 times 7, which is 56. Yeah? Okay. Then there's, of course, this rectangle, yes? How big is that? Just one sec. It's still LW. It's still 6 times 7, and it's 42. Everybody cool? Is everybody cool? Now, the only thing I haven't done is this one, yes? Why haven't I done that one yet? Because I only have the 7, don't I? Do I have this distance? Can I find it? Yes, because that was a 90-degree triangle, right? And 6, 8, when you do Pythagoras, you find that's 10. Every triangle, 6, 8, 10, 3, 4, 5. That's how they work. 6 squared is 36, 8 squared is 64, 64 and 36 is 100, square root of 100 is 10. Do I need to review Pythagoras?
Yeah.
Okay. 6, 8, hypotenuse, 90 degrees. Now, I know you've all been taught a squared, b squared, c squared, and I am trying to break you of that horrible habit. It is leg squared plus leg squared equals hypotenuse squared. Then you don't ever need to worry about letters. What is that number?
6.
So that's a leg, so it goes there. So it is 6 squared. What is that number?
8.
It's the other leg, so it goes there. Plus 8 squared. What is 6 squared? 36. What is 8 squared? 64. What is 36 plus 64? 100. H squared is 100. But I do not want h squared, I want h. So at the end of Pythagoras, you have to square root. What is the square root of 100? 10. Now I'm going to give you a gift that your previous teachers should have given you. 3, 4, 5. 3, 4, 5, always. Same with all the multiples of that. So if I multiply everything by 2, 6, 8, 10. If I multiply everything by 3, 9, 12, 15. Everybody cool? Always. You don't need to do Pythagoras if you have any multiples of 3, 4, 5. Because it's going to work. Everybody cool? That's my math present to you today. 3 of my grade 10 students are having a birthday today. This is my present to all my grade 10s. The 3, 4, 5 triangle. If you are from another country, you learned that in grade 2. Not your fault. All right. So now I know that's 10, yes? So that's 10. What's 7 times 10? 70. So now I have all the rectangles, don't I? Because there's one rectangle that is the 2 triangles from front and back. Then there's the diagonal rectangle, the back rectangle, the bottom rectangle, yeah? What do I do with those? Add them up. 8 and 6 is 14, and 2 is 16. Carry the 1. 5 and 5 is 10, and 4 is 14, and 7 is 21. 216, Tobby. Everybody cool? Now, if you have any one of these other answers, and you didn't show any work, do you know how to fix your problem now? No. Do I know how to fix your problem now?
Why did you
No.
length times width for all of them if it would be height times width and height?
Because I don't like using height and stuff, because height changes depending on how the shape turns. So I did everything as a rectangle with length and width. Because, Ariana, this rectangle right here that was 7 and 10 is diagonal, yes? It doesn't really have neither a height nor a width because it's turned diagonal, right? But if I turn that rectangle this way, 7 and 10, it quite obviously has a length and a width.
And you only
Cool.
solve the hypotenuse when it's a triangle?
You can only solve the hypotenuse if you have a right angle to work with.
Isn't a square, or like that prism, not prism, but
Which one?
One to the left, the cube.
This guy?
Yeah.
Well, this guy's right angles everywhere.
Okay.
Cool?
Yeah.
Okay. So let's come down to this one. Do I have a formula for this guy? Yeah, because it's one shape, right? So this guy must be 2 WL HL and what did I miss? WL HL and HW. So who has some answers for me there? Because that's just fill in the formula. 192. That sounds about right. Does anybody corroborate that? Does anybody else have 192? Other people? Okay, I think that's right. I don't remember, and I don't want to do all the math. Now we're in trouble. Because now is when, if you understand everything, you can do this. But there's no formula for this, is there? Because it's two shapes. Now in grade 9, you were taught one way to deal with this. A great many teachers do this move. They cut it in half, right? And they say, find the area, the surface area of 1. Then they say, find the surface area of 2. And then add them together. And then subtract 2 overlaps. How many of you have heard that? Couple, right? Okay. That's one way of doing it. That works just fine. Because if you split this in half, you can do this formula twice, can't you? And then just subtract the overlaps. What are the overlaps? It is the shape that is on both of them, which is right here, yes? If you find this area, which is the overlap, and subtract 2 of them, you will get this surface area. Everybody cool? That's one way you could do it. There's another way you could do it. You could split this up and just find every rectangle, yes? Could you find, is there 2 of these ones? Front and back. So if you could find that one times 2, yeah? Are there 2 of these ones? Yeah. That one times 2, yeah? How many of this one is there?
2.
1, 2, 3, right? Times 3. How many of the bottom one is there? 1. And then everything's covered, yes? Everybody cool? Yes. Shh. Get out of my head. That's what I'm about to talk about in a second. Stop it. It's mine. Leave it alone. Is everybody cool with that? And you'd get a whole bunch of numbers like we got up in B, and you'd add them all up. That cool?
No.
Yes or no? Okay. Now, let me offer you this. Ariana just made a point. Isn't this everything that I've colored in yellow? Isn't that top just the exact same as the bottom? It is, isn't it? So what if we pretended that this was just flat? Then it would look like this, would it not? And we could do the formula, couldn't we? Couldn't we do it? That's just a rectangle, yeah? But it's not like that. But if I did that formula, I would get this whole top, wouldn't I? Now, if I make it what it really looked like, I've got that whole top, don't I? So the only thing that is new is 4 of those, correct? So I could have done the bottom and then just added 4 of them. Does everybody see what I did? 1, 2, 3, 4. Does everybody understand? What makes surface area difficult is some of you don't see what I just said. Even though I just drew it, you're like, I don't get that. But then you try to get it. Do you understand what I'm saying? You're all trying to find the best way, which really means the easiest and shortest way, to get these answers. The problem is, if you cannot imagine other ways of how this could appear, then you cannot do the shorter ways. Do you understand? You must do piece by piece and add it up. Do I care which one you do? Absolutely not. You do you. Whatever works for you. If you want to learn some of the shortcuts, you have to be aware that those shortcuts change with every single shape. Right? Everybody cool? Because I could, one second, Ariana, I could have drawn another one out here, couldn't I? Right? And then if you're using my way, this part's already done. And then these 4 have been added. Picking up what I'm putting down? It is up to you to decide what works for you. I can give you a few tools to solve it, but then you got to decide how you're going to use them. And that is why surface area bothers you people so much, because there isn't a straight path from the question to the answer. You have choices. And until grade 9, grade 10, you didn't really have math choices, did you? Your teachers said, this is the best way to do it, do it. Right?
Yes.
Okay. I don't remember the answer for this, but I bet a few people are going to want to change theirs.
What does 12 and 4 look like? How do you...
So, well, let's talk about it. If I was doing my way, then the whole bottom would be 2, and it would be 12 by 4, right?
12 times 4?
Length, width, height, right? So there's my LW plus. Now, what's my height? You do know, because if this is 12 and it's been divided into 3 even chunks, how big is each of these? 4. What do these lines mean? That they're all the same. So you know that this is 4 as well. So 12 by 4 covers the bottom. 4 by 4 covers the side. Plus 12 by 4 covers the top. Yes? 12 by 4 is 48. Plus 48 is 96. Plus 16 is 112. Times 2 is 224. Everybody cool? And that is the whole bottom. What did I just find? I found all of that. Everybody cool? What is missing are these sides. What do I know about those 4 sides? They're all 4 by 4, yes? And there's how many of them? 4, because there's one at the back and one on the left. So now I have to add 4 squares that are all 4 by 4, right? So that's 224 plus 64, which is 288 millimeters squared.
So what the second 12 times 4 is that for the
That's for, I'll do another color for you, because colors always help. There is a 12 by 4 right there, and there is a 12 by 4 for that, because it's 12 by 4. And then the 4 by 4 is the blue right there. Everybody cool? Now, please notice how often I am breaking out my highlighter here. Right? It's helpful. Maybe you don't need it, but maybe you do. When you get to the quizzes and tests on this, it might behoove you to bring some pencil crayons or something so you can separate sides like I do in my notes. Everybody good? I see your hand, Gervier. I'm just going to make sure everybody's with me on the color thing. Does it bother me if you hand me in a test with all the shapes colored like this? No. Gervier, hit me. Okay. Are you cool with the 224 being all of this?
Yes.
You understand that, right? So the problem is the 4 by 4, yeah?
Yes.
So this yellow wasn't part of the green, was it?
No.
Okay. So how big is this?
4.
4 by 4. So that, there's one of them, yeah?
16.
Well, how big is that?
4.
4 by 4, right? And if there's one on the front, what's on the back? Another one. And if there's one on the right, what's on the left? Another one. So it was 4 by 4, and then there was 4 of them. Right? Because I had 4 by 4 to get this guy, 16, and then times 1, 2, 3, and that's the 4th one. You with me? Cool. Everybody good? Okay. Everybody cool? Yeah. All right. Turn the page over. What is wrong? Aw, damn it. I hope nobody tried F. Because F, there shouldn't have been a right angle triangle there. I was copying and pasting other shapes to build these. But it's okay if you use the right angle triangle there. We can sort it out. So, is there a formula for this? For this side of it? Yeah, right? Is there a formula for this side? No. But if I found this and I found this and I subtracted 2 of those, would I have the surface area? Yeah, that's how a lot of grade 9 was taught. I personally don't like doing that. When I get to something like this, I still do face by face. Understand? So, how many green rectangles are there?
2.
2. So if I know that times 2, I'm covered, right? Yeah. How many yellow rectangles are there?
2.
Times 2. How many blue rectangles are there?
1.
1. Because the other one is covered over here, yes?
Because of the triangle?
Right. Now, come over to here. How many orange ones are there?
1.
1 only. Because this diagonal one is different, isn't it? How many of the purple ones are there?
2. Wait.
1.
What?
That's this side, the outside of it. Right?
Underneath the same?
No. That's just this face of it.
Oh, okay.
Okay.
About the top.
And how many triangles are there? 2 times 2. So now I can start doing math, yeah? What are the easy parts? Is the green one easy? Sure. What is it? 8 by 3 by 2. Everybody cool?
By 3?
8 by 3. This is 8, like it says right there, and this is 3.
Okay.
All right. Is the blue one easy? What's the blue one? It's 3 by 3, and there's only one of them, yes? What's the yellow one?
8 by 3?
By 2. That gets me the yellow one. What is the orange one? That one's pretty easy to spot.
2 times 1. What is it? For the green one, what is it?
3, okay. By 4. That's my orange one. What's my purple one? That's tricky, isn't it? Because I know this is 4 and I know this is 3, but do I have that?
No.
But I just gave you that present.
So 4 squared and 3 squared.
It's 3, 4, 5, right? So it's 5, yeah? Four, 3, so that's 5, correct? So it's 5 times what? 5 there, and what there?
3.
3. That's my purple one. This oh, shoot. This triangle, Ariana, is 4 by 3 with a 90 degree in it. I just went over that on the other page. If it's 3 and 4 with a 90 degree, this is automatically 5 from Pythagoras.
Okay, so if that was 4 or 5, then the next one would be 6?
No. You got to multiply them. So 6, 8, 10.
Would I square the 4 and the 3?
You would square the 4 to get 16, square the 3 to get 9. 16 and 9 is 25. Square root it to get 5. Okay. No, of course it doesn't have to be in order like this. This is just all the sides. And the last one I need is the triangles, yes? Now, if that triangle is on the top, the bottom triangle is the exact same thing, isn't it? And 2 triangles make what?
Square?
A rectangle. And a rectangle is just length times width, right? Because squares are special rectangles. They're the only thing. A square, they're all the same. But it's just a rectangle. So this is just 3 by 4. I don't need to worry about dividing by 2 and multiplying by 2, do I? Because it's going to make a triangle or a rectangle. And then what do I do with all these numbers? Just add them, times them, multiply them, then add them up. 48, 9, 48, 12, 15, and 12. Right? 48 and 48 is 96, 105, 129, 139, 144.
Where do you get the 12? Oh, the 3 times 4.
Is the math complicated?
No.
The math is not complicated,
No.
is it?
It just looks...
It looks scary.
Yes.
But if I drew it this way, 8 by 3, then I drew it again, 8 by 3, then I drew this, 8 by 3, then I drew this, 3 by 3, and then I drew 5 by 3, 3 by 4,
So much.
and 2 triangles of 4 and 3, and another one, 4 and 3. Could you do it? Of course you could. You could have done this in grade 3. Was there anything stopping you from doing this many rectangles in grade 3 and then moving it to here? No. Nothing at all. If your teacher gave you 1, 2, 3, 4, 5, 6, 7 rectangles to practice in all of grade 3 or 4 or 5, then could you have done this grade 10 work? Yes. Everybody with me? It's just what you have known from the very beginnings of math. Blow it up and work on the pieces.
What's one thing in pre-calculus that we've never learned before?
In pre-calculus?
Yeah.
Like pre-calculus 10?
Yes.
I doubt many of you have done trigonometry. Exactly. Okay, which is unit 2, in case anyone cares.
Can you draw what that looks like?
No. Why would you borrow problems from the future? Let's get this knocked out of the park first. All right, now, ladies and gentlemen. So, is there a formula for this?
Yes.
Not for the whole thing. Is there a formula for the pieces?
Yes.
Yes.
So this is times
How many of them are there?
2.
Times 2. How big is that rectangle? 15 by 5 by 2, correct? Everyone happy with that?
Yeah.
Okay. How many of that blue one is there? Times 2. What's that one? 15 by 2 by 2, yes? How many of the bottom? And I'm just going to write BTM for bottom, because that's how my mom used to say about bottom, because she didn't want to say bad words like bum or ass. So my mom would always say, get your BTM into the car. I don't know why. It's like, Mom, what are you talking about? Your bum. And she would be all like, bum, because she didn't want to say it.
Oh my God.
I know, right? I'm 43 years old. I've never heard my mother say the F word. Never once. She says fiddle.
So does my mom.
Oh, yeah? Cool. And there's that Simpsons episode where Homer gets really mad and he kicks all the kids out of the room. He's like, kids, can you leave the room, please? And the kids leave and Homer goes, fiddle-dee-dee. My mom says fiddle-dee-dee. Anyway. Okay. How many BTMs are there? 1. And how big is it?
8 inches?
15 by 8. Everybody cool? And how many purple ones are there? Times 2. And what are they?
2 by
8 by 2 by 2. Is everybody cool to there? So now all we've got is this problem, yes? But this is not a problem, is it? Because if I take this triangle and turn it like this, isn't that just a length and width situation?
And what are the numbers?
And in this, well, you know the numbers.
5 and
If that's 5, what's that?
5.
5. So length and width is 5 by 5. And Ariana, look, you finally get your square.
By 2.
Not by 2. Because the triangle, there's 2 triangles. So it makes 1. That's the trick here. If you are memorizing formulas and memorizing what we do and not thinking about what you're actually doing, you screw up, don't you? So then, what do I do with all those numbers? Just add them up.
Because there's 5 and 5, they're going to be the same. Is that why?
Yep.
Because there's 2 triangles on each side.
Yep. So that's 150. That is 60. That is 120. That is 32. And that is 25. Then what do you do with those numbers? Add them up. That's how easy it is.
So the only stumble is the fact that it's the same with the 5 by 5.
In this case, yes.
We don't have to square root anything.
Not in that one. So, now that you've seen a few of these, I am betting, if I were a betting man, that if I walked around, I would find a great many people do not have G done. And if you do have G done, you may want to reconsider your answer to it based on what we have just done, yes? So take 3 or 4 minutes and have a look at G. Work with somebody else if you want.
Are the 2 lines indicating it's the same?
Yep.
Just
So the whole thing is 22, and these 2 are 2 equal parts of 22. So what is it?
22, is that 11?
Yeah, it's 11.
So one is 11, one is 2? Or is it just both 11?
They're both 11. That's what those lines mean. They're exactly the same. So 22 has been split into 2 equal parts. So they're both 11. That's why I use 2 little lines to see if I could fool anyone.
Okay, so I'll times it by 11.
All right, Ethan, let's see what you got. I think that might be right. Let me double check. Because I just went over this with another class. Oh, but I think I deleted it. Oh, son of a motherless goat, I did. No big deal. I'll just do the math real quick right now. Relax. Chill out, dude.
It doesn't tell you the way.
You have 400. You had the same number 3 times, yes? Not right. What? Yes, Donish. Nope.
Wrong as well.
Yep, wrong. That's a weird way to ask that. Is this wrong? Yes. So it's right? No. So it's wrong? Yes. It's like when you ask somebody, do I need to turn right here? Right. Or no. Do I need to turn left here? I need to turn left here. Right. So I need to turn right? No. Left. Left? Right. See what I mean? Yeah.
There's no width.
Sure there is.
The 2 is the height.
Okay, Ariana, you have a lot of trouble seeing this, and I don't know how to help you. If that is 6, then what's that?
6.
Then what's that?
6.
Then what's that?
6.
Then what's that?
6.
6.
So the 2 is up.
If that is 2, then what's that?
2.
Right, what's that?
2.
What's that? 2, 2.
Okay, and then what fools people is because it's longer? Is that why?
Maybe. I don't know what fools people. This question doesn't fool me at all. You feel like it's wrong, but you're going to come on up and give it a shot?
Yeah, I think that's right.
Oh, not quite.
Yeah, that's right.
No. See, I don't get it, man. I do not understand.
The 22? There's only one? Because it technically be this top, but it's cut into sections.
Yeah.
And this is 11.
Uh-huh.
So there's only one of these.
Okay.
22 times the width.
Yeah.
But I don't have to add like the times 2.
Well, isn't the bottom and the top still the same? Same amount of space, isn't it?
Cut it into the...
Yes, you did have to because you're adding stuff new. Okay. All right. How many people approached this thing by splitting it into chunks and adding up the pieces? Right? It takes a long time, but it'll work. Right? I could do that. I could do it all, yeah? And they're all just rectangles, yes? So it's just 1,000,000 lengths times widths, right? Let me show you something. I'm going to draw that, and I'm going to draw that. Now, what did I just make?
Rectangle.
I made a whole rectangular prism, yes? So if I had this, I could go 2 LW, HW, WH, right? And it would be 2 LW 22 times 6 plus HW 22 times 4 plus, and then the last one out here was 6 by 4, right? 6 by 4. Does everybody see what I did there? 2 and 2, because these are the same. Okay? Does everybody see what I did there? And if I do that, I get 468. Right? Everybody with me? Everybody cool? Okay. That's if this was one whole prism, isn't it? But it wasn't, was it? Why did I draw that green? Because that green is the only part that's missing, isn't it? When I cut it out, the whole roof still there, and this wall still there. So just that green rectangle is missing, yes? How long is it?
6.
It's 22 divided by 2, 11. And how tall is it?
2. 6. 2.
2. What's 11 by 2?
22.
22. And then it's missing again here, yes? Yeah. So it's 468 minus 44. Right? Which is 424.
So why did you subtract?
Because it's not actually there. It's missing.
When you add it, though, if you wanted to add another square there?
But I didn't. What I did was I visualized this wall out here. Because they're both there, aren't they? And I visualized this wall up here. But those two green walls don't exist, do they? Does everybody understand? Now, why am I able to do that? Because I am not jumping into the numbers. I am looking at what is being asked of me first. Do you all see the difference? Right? If there was a big pool of water beneath a diving board, would you just jump right in? That's a good intelligence test. Why would you not jump in?
Because you're scared.
Huh? It might be very shallow. Right? So what would you do? You'd walk in first and check if it was deep enough, right? If you dive straight into spitting numbers out on the page without thinking about what you're doing, what's going to happen? The same thing, right? You will do a whole bunch of work and you might be totally on the wrong track. Have a plan. That's all I'm saying. Everybody cool?
Are these kind of questions going to be on the...
Yes, because these are the kind of questions that you need to be able to do. And lastly, is this one single figure?
Yeah.
So is there a formula for it?
Yeah.
And it's right on your sheet. Surface area is
Cylinder?
2 pi r squared plus 2 pi r h. 2 pi, what's the r? 3 squared plus 2 pi, what's the r? 3, and what's the h? 8. Now, remember yesterday or the day before, whenever we talked about it, whenever you have pi, as you get more and more advanced in math, you're going to leave it alone. So what is 3 squared? 9. What's 9 times 2? So I have 18 pi's there, yes? Plus, what's 3 times 8? Times 2? 48 pi's there. If I got 18 pi's there and 48 pi's there, how many pi's do I have in total? 66 pi. And that, yeah, of course, meters squared. That is perfectly acceptable. Does everybody understand? But remember, that doesn't help you in the real world, does it? So you have to remember that this is in the real world. If you need an actual number, like to know how much paint you need to buy, then you got to do 66 times the pi button, which will get you something like 220. What is it really? 207? 7 blah.
Before you even did that, I just put 18 pi plus 48
Yep.
pi.
Yeah, some calculators will do that.
Instantly got
Yes, some calculators you need to push the times. I don't know what calculator everyone has, so if you do this, it will always work.
So yeah.
Everybody cool? All right, now, last question. I know nobody's done this. The day is about to end.
Well, no, 10:54.
Oh, all right, we got lots of time. Where in a room do you paint? The walls. Can you make an argument for the ceiling? Yeah. I'm going to make this easier on you. Just the walls. Now, I'm going to give you a warning. Read the question very carefully. You're only painting the walls, which means you're painting how many rectangles? 4. 2 of them are the same. The other 2 are different, yes?
4.1.
Everybody cool? Go. See if you can figure that. I know there's decimals. There's a reason there's decimals.
Okay. Down to the nearest 10.
If I were you, ladies and gentlemen, I'd draw a line in the middle and do my work on one side, because I'm guaranteeing there's a very good chance you did everything right but didn't think about what was actually happening. And I'll tell you why in a moment. Go. It's 2.0. 0.03 or whatever, right? Paint is sold by the gallon. In math, what would you do with that decimal? You would round it down to 2.
Yeah.
In real life, what do you need to do with that decimal? Round it up to 3 because you need that third gallon. Or you're going to leave a square of your wall unpainted. Now, I have lived in places where they have done that. You walk into the house, there's a picture on the wall. Oh, that's a nice picture. You take the picture down, there's a square of unpainted wall.
Why?
Because they didn't want to paint that last little bit. Or they ran out of paint.
Or just go get more.
But you're right, it is a waste of money. That is why everybody has cans of paint sitting in their garage half empty. And that's why the recycling people have to say, free paint recycling day. So you can get rid of all your old paint. Now, everybody cool? Yeah. Now, you've learned something new, but it's not really new, is it? It's taking area and putting conversions with it. Because you all could do that part already. Now you apply your new knowledge. That makes a square of 1 by 1, so that's 0.3048 by 0.3048. Everybody with me? There's another way to look at it too. This is how many dimensions? 1. So I would convert feet to meters once. But this is how many dimensions now? 2. So I would have to convert feet to meters twice. So I could have used 0.3048, but I would have had to do it twice to cover both dimensions. Everybody cool? What if I was going into the third dimension? I'd have to do it again. 0.3048 again. And that would take meters to cubed. Everybody good? All right. Everyone's cool? It was scary? I don't think it was scary. I think that's taking it a little too far, don't you?
So much.
But it's a lot of little steps, right?
The only reason it's hard for our brains to do it is because it's all mushed together with everything we learned.
It's making you go into all the corners of your memory and finding everything.
And we don't have a straight path to go there.
No. All right. You are now on page 33. This is I do like this font very much. If you look very closely at it, it's a very fun font.
Oh, that's weird.
I'll jump it up. It's a good timey font. See? It's little faces. Yeah, I like that font quite a bit.
I liked
Okay. Now, surface area is what? Describe to me where the surface area of this coffee cup is.
the bottom and
The whole what? Outside. The whole outside. Does everyone agree? Hey, Mr. Como. Whole outside is surface area, yes? How many dimensions does it have? The surface area. 2. Because I could peel this off and I'd have a rectangle, wouldn't I? Which is only 2 dimensions. And then I have the circle up top and the circle on the bottom. Everybody cool? Okay. Now what's the surface area? The outside and the inside. How many dimensions? Still 2. Because there's a rectangle outside, there's a rectangle inside. Both of those are rectangles, still 2 dimensions. Everybody good? All right.
So now we have to solve this.
So, no. Now, since it's a cylinder, can I fill it up? When I fill it up, how many dimensions does that have? 3. It's got a length, a width, and now a height, because I'm filling it all the way up. Is everybody with me? So what is the difference between volume and surface area? Okay. Okay. Good. Who else has something to add to that? If you didn't hear Ethan, he said the volume is what's inside and the surface area is what's outside. Is that the only difference? What's the other difference? Well, it is the amount of space an object contains, but let's explain that. Why did I do that whole thing with the dimensions? One of them's two-dimensional, one is three-dimensional. I can make the surface area of this with flat shapes, can't I? A rectangle for the outside and two circles. Can I make the volume that way? No. Everybody cool? Okay, let's go to the next example. A piece of paper, yes? Everyone agree?
Yeah.
Could you measure this?
Yes.
We could measure that easily with a ruler, yes? Could I measure this?
Yeah.
Okay. The way you are facing it right now, how many dimensions does it have? Two. It's got a length of 11 and a width of 8.5. Everybody cool? But in reality, how many dimensions does this have? 3. So this thing really has volume, doesn't it? It's taking up space in the universe, yes? How much space in the universe is it taking up? It's taking up 11 by 8.5 to cover this much. How much space is it taking up that way? Can you, right now, with the stuff on my desk, and you can come up and have a look if you need to see what's on my desk, can you, and you can talk about this in any size group you wish, with the stuff on my desk, can you accurately measure the thickness of this piece of paper with everything that's on my desk? I'll give you 2 minutes to talk about it. You can. Go. You can come up and have a look at my desk if you need to. You have 2 minutes, and I'm setting the timer right now. You can look at everything on my desk and see if you can come up with a method.
That's not gonna work.
Do we use the fork and a plate?
Everything on my desk is at your...
Wait, what is this?
Everything on my desk is at your disposal. Go have a look if you wish.
Use this.
What about the rubber band?
This is my poker face. That's how you wake Lady Gaga up.
Very small things. It's
Poker face.
Slime thing.
It's also why you should never change in front of a Pokemon. Because he might Pikachu.
Stop.
No, how do you get a million Charmander?
I'd say that
Pokemon.
we could.
I know, right? All this in brains too. I like how 4 people are looking around my desk and everyone else is just like, screw it. He'll tell us the answer in a minute. That's not my
That's
desk.
not your desk, great. They grab my What do you mean?
Wait. We could try.
Yeah, okay, here you go,
Be honest, you got nervous when Mr. Como came in.
Nope. Why would I get nervous when Mr. Como comes in? I know how to do my job. That would be like saying a mechanic was nervous if there was another mechanic near him.
Oh, count. Count.
Use other paper.
That's what he's doing.
I do not.
You're already talking about it. I got up.
But you can use tape.
Tape, it
I
doesn't
just-
have
I just
numbers.
added
Wait,
it.
you need numbers to measure volume?
Well, to measure anything, you need numbers. You can't just say it's
Well, then how do
Kaboogly Heinz Nickel Fritz is thick. Time.
Shoot or something.
Did you actually put that on? Did you? Serious?
All right.
We should just keep that on.
Who has an idea? And I know Joseph has an idea because Joseph's absolutely right. But let's hear Ethan's first because I know yours is right.
You stack like 30 pieces of paper together, and then you measure that because it's so thick, and then you divide by 30.
Wow, he stole Joseph's idea. Does everybody understand?
Oh wait, but how do you know to?
If I take 30 pieces of paper,
Why 30?
doesn't matter.
Okay.
If I put 1,000 together and I measure that stack and I divide by 1,000, do I now have the thickness of the piece of paper?
You divided 1,000 with
if I had 1,000 pieces of paper and I measured it and divided by 1,000.
Whatever that number was.
Okay. Is everybody cool?
Yeah.
All right. Now. No. Gummy bears are to be given, not asked for.
Oh.
All right. Now, did any of you take 1,000 pieces of paper, measure it, and divide by 1,000? No, you didn't. So I'm going to ask you now, could you give me, and it's not necessarily centimeter or inch or anything like that, could you describe for me the amount of space this is taking up in the universe? Pardon me? Okay, not quite. I heard one word there that I wanted.
Less than
No.
paperclip.
No.
Then.
What is this? One piece of paper. So how much space is it taking up in the universe?
Half paper.
One piece of paper. Everybody with me? All right. So this piece of paper, which is 8.5 by 11, other way around, 11 by 8.5, and one piece of paper thick, is taking up one piece of paper in the universe. Yes? Everybody agree? Yeah. So this rectangle has been repeated one piece of paper, right? Yeah. So if I know this area and I multiply by one piece of paper, do I have the volume of this piece of paper? Does everybody agree? What happens if I take that one piece of paper, which we know its area, 8.5 by 11, and I stack it up? What happens to the 8.5 by 11? It multiplies by what? By the up. Is everybody with me? So this is one piece of paper. This is 125 pieces of paper in the universe, yes? So if I take that measurement and I repeat that shape up, I know the volume, don't I? And we already know what you call it when you take a shape and repeat it. What do we call that? Starts with a P, ends with an M, and has Riz in the middle of it. It's a prism, yes? So that tells us that the volume, why is that coming up? That's not supposed to happen. The volume of a prism must be the area of the base shape, right? One piece of paper multiplied by what? Multiplied by how many times I repeat it, which is the height. Does everybody understand? Is everybody with me? Now here's where you're going to mess things up. First thing that comes into your head, where is the base of a shape? Bottom. It's the first thing that comes into your head every time. Is it the bottom? No. No. What is the base shape of my coffee cup?
Around it.
A circle. Right now, where is the circle?
Bottom.
On the bottom. What is the base shape of my coffee cup?
The circle.
Where is the circle?
Side.
On the side. What is the base shape of my coffee cup? A circle. Where is it?
Top.
Can you even describe where that is? No. So I'll ask again. What is the base? Is it the bottom? Why is the circle the base of this coffee cup?
Because it holds everything up.
Because the circle repeats all the way up. So the circle's the base. Everybody with me? Right now, the circle repeats going upward. So it's easy to call this the height, isn't it?
Yeah.
But if I turn it this way,
The height is this.
you're going to say this is the height because ground to top. It's not, is it? What is the height of the cylinder? It's still this. So the base is not the bottom. It is the shape from where you start. The height is what?
The base.
The direction that base is doing what? The direction the base is repeating. So no matter how I twist it, height is always away from the base. Is everybody cool? So that is what you need to know. The base shape is the start shape. No matter where it is in space, the height is the direction the base repeats. Now, that's a prism. We've also talked about what? What's the other thing we talked about? What's the other shape we've talked about so far? Starts with a P, ends with a D, has iramid in the middle of it. The volume of a pyramid. Now, use your brains. Is a pyramid related to a prism?
Yes.
How?
Because it has surface area.
Yep. How else? It's got a volume. How else?
A base.
It's got a base shape that repeats, yes? Okay, so since it's related, I must have to do the area of the base, and since it's repeating, there must still be a height, yes? I'm spelling height wrong like a moron.
Oh, you don't hurt yourself.
No, I'm okay with it. When I do something stupid, I'm okay with recognizing that it was a moronic thing to do. Everybody agree?
No.
Now, there's a problem here, isn't there? Because if I want to, for example, drop an ice cream cone in here, it's going to have the same circle at the top, isn't it? But it shrinks to nothing, yes? So is its volume more or less than its related prism? Less, because there's going to be empty space in here if I drop a cone in there, isn't there?
Because it's not big enough.
So, math guys did a ton of experiments, and they realized that if you have a prism and you have the same related pyramid, so cylinder relates to a cone, rectangle relates to a pyramid, everybody cool? Then the volume always is divided by 3. Because you could fit 3 cones of that circle inside this shape. Yes. Spatially wise, it wouldn't actually fit. Everybody cool? And they found that with experimentation.
And that's the formula?
That's the formula for every pyramid. Now, your job for homework tonight, you have 5 minutes, you can start on it right now, is to go back to page 27 and find all the volumes up to 29. So you need volumes of page 27 to 29. That's the first bit of your homework. So that's only 4 volumes, right? And then I want you to attempt the volume of D and the volume of F. I am asking you to do 6 questions for homework. I do not think that is a lot. Is everybody good? 4 questions on 27 to 29 and D and F. Everybody cool?